arc of blue electrons flowing through the air 3 to 5 feet. I wanted to shield the radiation from knocking the power out in my local power grid. As it was, I got a visit from the FCC the next day who said, "We know what you're doing and we want you to stop doing it."
This is EnergyCast, and I'm Jay Dowenhauer. Today we are talking about harnessing energy from lightning. How would it be possible? Is it possible? And would it be worth it? After this episode, some of those questions may still be left unanswered, but our guest today is one of the only individuals perhaps crazy enough to try it, and his story is definitely worth telling. I have to tell you, for longtime listeners of this program, this was the most freewheeling interview I've ever done. At one point, I pretty much threw away the clipboard and tried to hang on for dear life to the story I was hearing. And I'd also like to get it out of the way that it was my dad, of all people, who gave me the idea for this episode. A few weeks ago, he sent me a text message saying, "My thought has for a long time been, how could we ever get to harness and store the tremendous energy in lightning?" Well, Dad, this one's for you, and boy, is it a doozy. So when we think of lightning to energy, we typically think of this. Yep, all good children of the 80s know by heart that Doc Brown required 1.21 gigawatts, he meant gigawatts of electricity, to get Marty McFly back to the future. By the way, as one of the children of the 80s, I always say the best time to be a kid was pre-internet, mid-Reagan. Speaking of the Gipper.
Who's president of the United States in 1985?
Ronald Reagan.
Ronald Reagan? The actor?
So, how many gigawatts are a bolt of lightning? It turns out a lightning bolt actually contains 10 billion watts, or 10 gigawatts, which is about 8 times what Doc Brown really needed. Hopefully he was grounding some of that juice, otherwise the DeLorean would have been toast. However, this insane amount of power is near instantaneous. As our guest will describe, the entire lightning event lasts about 5/1000ths of a second. And since we require electricity to last over a continuous period of time, kilowatt hours and such, this 10 billion watts isn't much energy in that sense. Any attempt to harness lightning would require a way to attract it to your source. The best resource we have in the United States is University of Florida professor Martin Uman, who mastered the art of shooting rockets in the sky attached to copper wires and attracting gorgeous lightning bolts below. However, even Dr. Uman doesn't believe lightning for power is viable. He wrote me back personally and told me to read the first chapter of his book. Years after graduating from college, and I'm still getting homework. Then there's the question of storage. Now, most of you would think a chemical battery would do the trick. My guest also liked that idea, but I'm thinking of something more like a capacitor, which is like an uninterruptible power supply. I've done a few projects at work with capacitors, and they're pretty nifty at ultra-high voltages. Now, that's the most direct way to create electricity from lightning. There's another inventor out there who has a method for harnessing lightning to instantaneously convert chemicals into hydrogen. Maybe that's the answer. But when you think about it, every year we look up at the sky and these enormous streaks of light remind us how tiny we are. No doubt they inspired early scientists to explore the mysteries of electricity. Perhaps it exists only to inspire us to create energy through other means. But you'd have to think that there has to be a way to ultimately harness this renewable resource for our energy purposes. My guest today is Steve LeRoy, an inventor based in Illinois. Steve has over 40 patents covering many other sectors than just energy. When Dr. Uman shut down the lightning to power notion, I started looking around at anyone who actually built a device. According to a 2007 article in the New York Times, Steve was mentioned as an inventor of such a prototype. He was a little difficult to find, but that Times author pointed me to this video on YouTube.
Hello there, world. My name is Steve.
And
not knowing any other way to reach Steve, I left a public comment on that video's page, and thankfully Steve got back with me. But then I hit another snag. Initially, Steve didn't want to talk. You see, that Times article also mentions that Steve's designs were used by a group calling itself Alternate Energy Holdings, run by a businessman named Don Gillespie. It turns out that Mr. Gillespie has a pretty spotty record, being honest, and since 2015, reports say he's wanted by U.S. Marshals for alleged wire fraud in a scheme to build a $10 billion nuclear power plant in Idaho. You can't make this stuff up. I've alluded in the past to dealing with people like this myself, just crooks. One guy I worked for, who defrauded the parent company out of a few million, threatened to sue me for calling him a criminal. I later learned he had no shortage of people he'd screwed in the past, and I heard he now gets around with a bodyguard, because so many people want to get him. The owner of that parent company I mentioned had gotten so frustrated with trying to settle matters through legal means that he once shouted in a busy restaurant, "Can't we just kill the guy?" Adding that it's not expensive to have someone killed, it's expensive to kill someone and not leave a trail. So needless to say, Steve and I were kindred spirits in a way, and the next day after declining, he agreed to do it. I'm glad he did, because I think there are some valuable lessons here for any brilliant inventors out there who are eager to get their technology out into the world, but should be careful because the world is full of wolves. I hope you enjoy my conversation with Steve LeRoy.
We're here with Steve LeRoy, inventor. And Steve, I think the first question is, what is the single biggest challenge for harnessing lightning for power?
I would have to honestly say getting a lightning bolt to strike your conducting rod. Lightning is very erratic. There are ways to trigger it. I know they've been experimented with, but the single biggest challenge is actually getting the lightning strike.
Where all your equipment's located, right?
Where your lightning strike conductor is located.
Right. And in reading up on this, it seems that you would need some sort of capacitor, right, like a battery, essentially, to store.
Well, when I wrote my patent application, lithium-ion technology had not come out yet, but you would need a capacitor of some type. I was experimenting with the Maxwell technology ultracapacitors, which were measured in farads, not microfarads or millifarads. And we've come a long way since then with capacitors, but the problem is, Jay, they take time to charge or they will overheat and explode.
Is there any special design of capacitor that might be better than lithium-ion batteries?
Nothing charges as fast as 1/200th of a second, especially for that much energy.
What about industrial? I work in the utility industry. What about the capacitors that we have, say, at like substations? What about something like that would be a little bit larger?
You would have a
industrial?
spectacular fireworks show. It would be an overload. It would be seen by the circuit as a mass overload.
Mm-hmm. So in addition to be where the lightning's striking and the capacitor being able to store that kind of energy, right?
Some type of capacitor or battery that could charge in 1/200th of a second.
Any other technologies that you think would be at least a promising direction for something like that?
Well, I know that there are ways of delaying the current a little bit, and my competitor with the first name of Todd, he mentions that he's fighting for the rights to a patent in the internet search that uses brine water as a kind of a brake to put on the electric current, and he also claims to generate hydrogen by doing this. However, I think hydrogen and lightning bolts are a poor mix.
Because of what hydrogen can ultimately yield, right? Yes. I think some people are still a little bit confused about exactly what is in a lightning bolt. Let's talk about the energy potential that is there. And energy, as we understand it as utility customers, is that it's measured in kilowatt hours, but lightning is about 5/1000ths of a second.
Right. There's one flash that's 3/1000ths of a second and two additional strobes of 1/1000th of a second. My design, my lightning strike tower, tower itself was grounded into the ground with brine solution to help attract a lightning strike. I had circular coils 5 feet away from the lightning strike tower to capture an expanding and contracting electromotive force field, the corona discharge, so to speak, of the lightning strike. As you may know, many people are killed when lightning strikes near them because of the amount of energy surrounding the bolt.
And so you were trying to capture the corona as well?
Yeah, the corona discharge, the electromagnetic field I was attempting to capture as it expanded and then as it collapsed. So I would get double my money, so to speak. I would get the field as it expanded out, and then I would have to put it through an inverter to turn AC into DC, but then I would get more of the field as it contracted back to the lightning strike tower after the bolt finished.
You said it was a pole in brine, so it was basically like standing out in a lightning storm with an umbrella in a swimming pool, right?
Well, that would be the equivalent of it. I wouldn't recommend somebody do that.
No.
But if you saw the pictures I sent, you will see my lightning strike tower consists of multiple strike rods in a circular fashion so that I could expand my chances of attracting a strike. And they all had a sharpened tip. A very sharp tip on a conductor ionizes the air around it specifically to attract lightning. That's how lightning rods are made, Jay.
And you said that you were converting AC to DC.
Yeah, lightning is alternating current.
Okay. And I think we also understand lightning to be static electricity. Is that right?
Well, it's a huge static discharge.
Right.
It's an enormous static discharge. It's not the kind that you get when you walk on the carpet and touch something metal in the house, get a little zap on your finger. These are energies up in the atmosphere that grow to such potential that they can break the reverse breakdown voltage of air. Lightning bolts can be miles in length, and that has to be a huge amount of energy built up in the clouds. No one still knows exactly why lightning strikes where it does.
I think it's always been his understanding that the atmosphere, there's positive charges in one area and negative charges there, and there's a discrepancy there, and that causes...
Right, and there are reverse lightning bolts, too, where lightning comes out of the ground and goes into the sky.
Okay, so lightning is both static electricity, really, and it's alternating current, right, which I've always...
Yes, because it's strobing on and off.
It says in your technology, it says you used a Tesla coil, and then how did you add to that design? And first of all, maybe take some of us through what a Tesla coil is, because it's not...
Well, a Tesla coil uses an energy source like a plug in the wall, and it increases through the windings. There are primary windings and secondary windings, and it increases the potential to hundreds of thousands, if not millions of volts. And what I did was I had a large Tesla coil I designed, and I ran it off of 220 volts AC to create very large static discharge, about 3 to 5 feet in length, and it struck the top of an aluminum rod, which was grounded, and I had 5 winds of number 10 wire about 3 inches around the base of the aluminum rod to collect the electricity over a 2 to 2.5 second period of discharging the Tesla coil to simulate a lightning strike, but to add just a little more since I wasn't actually dealing with a lightning strike. I then took that electric current that I gathered and put it through a load resistor and a diode network to change it into 12 volt DC, and I had an array of 4 1-farad capacitors, which were at that time in use for audio systems in cars.
So it was literally
that was enough.
It was off the shelf, huh?
Then I discharged the 12 volts into a 120 volt AC converter to power the 60 watt light bulb for approximately 20 minutes. It was more like 18 minutes. Of course, it was bright brighter in the beginning and gradually grew dimmer until it went out.
A Tesla coil, is that similar to a voltage transformer? What's the difference there?
Yes, except the power goes into a disc on top of the windings that builds up a tremendous electrical field that actually shoots out lightning bolts. If you're not striking something, it will simply create a thunderstorm effect, which is quite dangerous indoors because it gives off deadly ozone gas. It ionizes the atmosphere.
And I think we've seen images of that, the famous images of Tesla sitting in a chair under the coil with all the lightning sparking around him. Right?
Yes, he built an enormous Tesla coil that set the Boulder Springs, Colorado generator on fire. He threw a short circuit on the line. He built his coil substantially out of conductors of copper that were 3 inches thick, surrounded by insulator.
And so you used that as a starting point and then developed your design. So now look,
I scaled it down. I wasn't creating 100-foot lightning bolts.
No. What you were,
it could be heard 25 miles away, as Tesla's design did.
Now, of course, you were able to capture, you simulated what would be a lightning bolt, right? And then you were able to get 100
Right. I had an arc of blue electrons flowing through the air 3 to 5 feet to my aluminum rod. It was the closest thing to the Tesla coil that I had in the garage setup I was using. I removed all flammable materials from the garage, pulled the cars out, of course.
I was about to ask why you didn't do this outdoors.
Why I didn't do it outdoors?
Yeah.
I wanted to shield the radiation from knocking the power out in my local power grid, because when you're creating that kind of electromagnetic radiation, you can put feedback into the power lines and you can actually blow a circuit.
Oh, so you were worried you were actually going to affect the distribution lines you were near, huh?
Near me, yes.
Yeah.
And I was cautious not to throw my town offline, or I would have gotten in a lot of trouble. As it was, I got a visit from the FCC the next day who said, "We know what you're doing and we want you to stop doing it."
How do you think they knew about that?
A Tesla coil is kind of like a spark gap transmitter, which is a very illegal device to build and interferes with police communications, emergency communications, normal radio and TV communications. They have arrays of antennas set up nationwide to detect spark gap transmitters, and they zoomed in on me and showed up the very next day early in the morning pounding on my door.
And I'm sure it didn't go any further than that, right?
No, I just told them I was experimenting to harvest lightning, and they said we would appreciate it if you wouldn't run your Tesla coil anymore.
Now, what was happening here was the same thing as if you're listening to the radio during a thunderstorm and you can hear...
Exactly, you hear the static.
Especially AM radio, right?
AM in particular is very susceptible to lightning static.
And so there was a break in those wavelengths, and that's how they were able to detect it.
They zoomed in on me. They triangulated my location.
Wow. Now, I also want to make clear exactly what breakthroughs you were able to make in this single experiment in your garage.
Well, I was able to store lightning out of induction. I didn't have a direct link up. I never shunted the power to ground.
Let's clarify that. Why is it so important to make this point that you didn't shunt it to the ground? What does that mean?
The lightning strike to the power rod went to ground. That is true, but I was collecting the electromagnetic field, which was not shunted to ground. It was hooked up directly to a resistor capacitor network.
Okay. And so is it a cheat to shunt it to the ground? All of the energy
you'd be
going
losing
to
power. You'd be wasting power.
So the idea would basically be if you're shunting, you're creating a grounding rod where a lot of the electricity would go to
You're
ground.
grounding your collection wires, and that wastes all the electricity you're gathering.
You weren't doing that at all. You were taking the full brunt of whatever energy was coming.
The electromagnetic field I created, yes.
And that's a big breakthrough in of itself, right? Because otherwise you're getting a bit of it.
Well, I was granted a provisional patent, and the patent office is very picky about granting those. You have to come up with something truly unique to do that.
I'm curious about this. In a real-world commercial setting, would it make sense to have it where a capacitor or a battery, something that could collect lightning energy, could defer some of this energy to ground, but collect a little bit of it? Would that keep some of these capacitors from being overloaded?
Well, lightning is so powerful, Jay, that it would jump right through the insulation. We know this from when lightning strikes power lines.
Nothing goes to ground, just takes everything out.
It blows the transformer immediately.
Or at least definitely trips the breakers and all that.
Yeah, it goes through the whole power grid.
Yeah, so let's get to the business end of this story. And I've been in situations like this before and want to walk through this. So according to the New York Times, and that's how I found you, a company calling itself Alternate Energy Holdings, it says they purchased your design.
They never gave me a penny. They gave me a worthless stock certificate of unregistered securities that were restricted. It was a non-negotiable document.
And what made you...
I signed a contract to license the technology to them.
How did you find out about them? Or how did they find out who?
Well, I met this crook, Don Gillespie, who is now a fugitive from justice after stealing $38 million worth of investors' money in a pump-and-dump Ponzi scheme, which I face no liability in saying that. You can just Google his name and find out what kind of trouble he's in.
Yeah, it's out there.
He's wanted. He's a wanted man. He's assumed dead and buried under a different name. But the money is overseas.
So how did you get involved with these folks?
Okay. Don Gillespie was working a different company at the time called IPO Assist, Initial Public Offering Assist, in 2004, where you would incorporate in Nevada, have shares issued, and after 1 year begin trading on the New York Stock Exchange based on the success and or failure of your concept. I must say that Don Gillespie's most serious charge was securities fraud and wire fraud. He finally issued a stock certificate to me in 2009 that was unrestricted. He ordered me to sell all the stock between a nickel and a dime a share way before it went up to $1 a share, when he had in fact formally promised to give me 3 times the amount of the share value at its maximum peak, which would be $3 million. So I can say in all honesty that Mr. Gillespie owes me $3 million and defrauded me out of that money.
And did you have I think a lot of people have been guilty of this before if you didn't, but did you have a lawyer looking over all of this at the time?
Well, I had a contract with him.
Yeah, but did you have a lawyer looking over whatever contract he put in front of you?
Oh, sure. I had my patent attorney look it over.
And what was he saying? Like, yeah, seems good, yeah.
He said, this doesn't sound like such a good deal for you, Steve.
So he had this guy's number from the beginning.
Yeah, he said, this guy, there's a lot of things about him that raises red flags in my mind when I talk to him. Don Gillespie doesn't always stay on point when you're talking to him. He's a Southern boy. He's a bit of an evangelical. He always wants to pray over the phone when you're talking to him.
You know what? I had a guy who I have dealt with, and if you are listening to this, you know exactly who I'm talking about, who would want to pray over the table, all that kind of thing. And as a practicing Methodist, I can tell you that that was probably one of the most offensive things to me after it was all over with. So things weren't seeming on the up and up, at least your own patent attorney.
By the way, I have nothing against Southerners. I think they have a beautiful culture.
Well, you're welcome.
I'm just saying
that guy myself.
He was of the type that couldn't keep his mouth closed for 5 minutes.
He was a wheeler and a dealer, huh?
Oh, he was a con artist, big time.
And I assume I know this type, very charming.
Extremely charming and very professional. He would come off as a great pro. He bragged to me in 2005 that he had it down to a 2-minute speech for his church friends to talk them out of their life savings to invest in his company.
So he was sharing with you about how he was able to con other people out of their money.
Long before he conned me.
And I've seen that happen too, where they show their cards about what they're like, but we're friends, so it isn't going to happen to us. Kind of the snake isn't going to bite you.
Right. In psychology, we would call him a sociopath or a psychopath.
Yeah, I think we all, people listening to this are definitely going to know that type. So the patent attorney seemed to have the smell test. It wasn't passing muster, but had you heard any stories about him doing this and other business dealings in addition to him kind of telling
No, I
stories?
wasn't able to dig up any dirt on Mr. Gillespie. He initially raised $40,000 for me in convertible bonds and only gave me $8,500 of it. He pocketed the rest, leaving me the fall guy to pay the money back in a year's time at 10% interest.
Because your name was on all the stuff.
My name was on the convertible bond.
Okay, yeah.
Which I never understood to this date how it worked. It was a complete con job for money.
So let's get to the part where you're in Illinois. They went down to Houston with your patent, but I take it that you were not.
I was
with
in the
them.
dark about it while they were doing it. He didn't tell me he was doing this.
Why didn't they want you, or why didn't you go down to Houston for these tests?
As soon as he had his hands on the license, he dumped me.
Did he have somebody else who's acting as the chief technology officer with you not involved down in Houston?
He didn't have me involved one bit, Jay.
Was he now the de facto scientist in this group?
Yes. He considered himself to be an expert after reading through my long patent, and he made a big mistake.
So he took your idea, and then without any other experts or any other people with PhDs or nothing, he did it himself. And as the New York Times also said, he couldn't make it work.
No, he couldn't make it work, and I can see why. They used a piece of pipe, which is cylindrical, not pointed. They probably planted it into the ground. They probably welded a wire to it. Had it been struck by lightning, they very likely would have been electrocuted. And he also electrified the pole. I don't know how he did that.
The New York Times story, just kind of put this in perspective for the listeners here, is that your dealings with him happened around 2007. Then his experiment, which he then said failed, happened in 2007. And then the story I came across was that in 2012, he was charged with conspiracy and securities fraud for promising to build a nuclear plant in Idaho.
Yes, all he wanted was my patent to pump and dump his stock. He wanted something spectacular to say that he was doing to attract investors on Wall Street. And if there are any Wall Street people listening who are multimillionaires, please compensate me for what Don Gillespie stole from me if you have a conscience about money.
Well, there you have it. This idea of him defrauding a town by promising to build a nuclear plant in Idaho, this goes far beyond the music man here. As someone who works in utilities, I cannot imagine someone can come into town and say, me, myself, is going to build a nuclear plant in your town. There's so much more involved in something like that.
He needed to raise $10 billion for that.
So who in the world would have been convinced that this one guy who no one's ever heard of,
no one was ever convinced of it, Jay.
The town in Idaho?
No. They finally granted him a permit to have a construction site. With $1 million he made off of my stock, he purchased some land. All the Idaho papers were touting him as a great businessman who had nothing and suddenly had $1 million. Well, that was my money he suddenly had, Jay.
And that's what he converted to do this work on this nuclear plant project.
Oh, he had the nuclear plant in mind all along.
He was telling you about this when he was working with you?
Sure. He told me that his corporation was to build a nuclear power plant, and he wanted as many patents as I could come up with so that he could use them to promote his stock.
Almost kind of using this intellectual property as collateral.
He was trying to use me, Jay.
Yeah.
He was using me.
Well, I have no doubt about that. So this guy Gillespie, I take it he hasn't reached out to you. So he fled in 2012.
No, he fled in 2015 when he missed his 2 court dates when he was to be sentenced.
Okay. This all happened in 2012. He then left.
And his girlfriend is rotting in federal prison right now. She stuck around for the trial.
How was she involved in it?
She was spending huge sums of money.
You think she was
an unwitting partner in crime? I think she shouldn't have been in prison.
Yeah. And these stories, they're sad, but they're also in a way unbelievable because it's like, how can you believe that somebody could get away with so much?
Well, a sociopath has no conscience, Jay. They have a conscience, but they've learned to tune it out.
Was there anything else that you witnessed him do during the time you spent with him? You said that he bragged about being able to talk people out of their money.
Well, he was constantly threatening to revoke my stock before I signed it over to him. I said, you know what, Mr. Gillespie, take your damn stock back. Here it is ripped up. I'm signing the signing portion of it to AEHI. Take your stock back.
Did he ever, with you, sit down and go through his grand plan and you could tell those wheels were turning?
I never met the man.
Wait a minute, you never saw him face to face?
No, it was all over the phone or over the internet.
Interesting. And you never met with anybody, never sat and talked to anybody face to face?
I never so much as shook his hand, not that I would want to.
Well, that would definitely. Do you think you would have gained something by seeing him face to face?
No, I think I would have lost something. I think he would have tried to intimidate me.
Is that how he came off, as kind of a bully, intimidating?
He was a bully.
Yeah.
Jay. The man was a psychological bully.
Yeah.
Con artiste, an absolute artist at conning people out of money.
What did he tell you his bona fides were? Did he tell you, hey, I've done this deal and this deal?
Well, he had a good military service record, I must say that for him, in the U.S. Navy.
Well, we salute his service. But did he kind of say, like, hey, I did this other project in such and such place? Or
he said he helped a lot of people become millionaires, which is a lie.
Was anyone else interested in your technology besides him?
Sure. I can't mention them for liability reasons, but I had a number of people interested.
They didn't offer that kind of money that he was offering, I take it.
No, he was offering pie-in-the-sky amounts.
Yeah. And it never occurred to you that it might be too good to be true or anything?
Look, the fact is, Wall Street owes me $3.3 million.
How much of your own money did you put into the initial experiment?
The total amount was $42,500 over a period of 4 years, including legal costs. Patenting something is very costly. Over $20,000 I spent on the provisional patent, and he wasted it. He never applied for the utility patent. He let it expire and threw it in the garbage.
Why do you think he did that?
Because he was deceiving me all along.
You don't think he had any interest in the actual technology?
He never had any interest. He talked to my patent attorney about getting a utility patent, and the patent attorney said, fine, send me a check for $20,000 and we'll start the process. And Don Gillespie said, wait, I'll offer you stock. And my patent attorney says, I'm sorry, I don't accept penny stock as payment for legal services.
So let's get back to your technology. And you've told me, we've talked a little bit on the phone before this, you say you think your own design won't work, even though you were able to demonstrate power with the light bulb, and you think that,
I don't think we have capacitors or batteries that can charge anywhere near fast enough, 1/200th of a second. See, there's a difference between power and energy. Yes, there are hundreds of millions of volts in a lightning bolt at thousands to tens of thousands of amps, but it only lasts 1/200th of a second. When you do the math and convert that to kilowatt hours, you get maybe 20 minutes of 1 kilowatt continuous. Enough to run your refrigerator for 20 minutes.
Look, some people think that lightning is energy. Is there any situation 100 years in the future? Do you think anybody would maybe be able to take some sort of version of what you've done and turned it into something that would work?
Kind of hard to speculate 100 years in the future, Jay, with technology.
Yeah.
I think there are other forms of energy that are far more lucrative right now, like wind and solar.
Yeah. Any nuggets of what you worked on that you think are worth someone else taking?
It's possible somebody could pick it up long after I'm deceased and try something new when they do have batteries that can charge in thousandths of a second. But this is fantasy world.
Do you think there is a way to take lightning and convert it into something chemical, unlike a battery, and maybe that would be a way, a medium, to take the energy created from lightning and
I'd like to see him try.
And to sum this up before I go into our, no pun intended, lightning round, but before we do that, this experience was definitely not pleasant, to say the least. But I think a lot of people out there have had this kind of experience. And I think there's a lot of people out there who have a lot of very promising energy technology.
I encourage them not to give up on their dreams.
But is there any cautionary, definitely lawyer up every time and maybe trust your gut, maybe the gut?
Definitely lawyer up before you get into a money deal. Before money changes hands, lawyer up.
And I think the other lesson also is that even if you're getting into something with people who you trust, money changes people.
Incredibly. Like night and day, Jay.
Well, let's hope that this will reach some people who are
I hope it reaches Wall Street and I get my $3.3 million. They can send it to you and you can send it to me.
There's no need for me to be involved. If you get a dime, I think that would definitely be some justice there. But look, this stuff starts with inventors like you who have the spark, and hopefully maybe before the end of it, there'll be some sort of justice. But
I've laid it to rest, Jay. I've let it go.
Yeah, and maybe that's the best thing to do too. I'm one of these people who don't let things go easy. But look, hey, I do really appreciate you sharing this story.
Well, Jay, it's been a pleasure to have this discussion with you.
Well, Steve, I tell you what, this is my favorite part. This is my lightning round of your thoughts on different energy technologies, starting with natural gas.
Our best bet at this time.
Crude oil
has environmental issues. I'm not against it, but I'm not a big fan of it.
Nuclear.
Very promising as technology increases.
Coal.
Coal is dirty burning. I'm against it.
Wind.
Wind is a great technology. It's very expensive to build a wind tower, however.
Solar.
Solar is terrific. I like the grid tie systems they sell for houses for $40,000 that you can put on the southern roof of your house and feed into the power grid when you're not using up the electricity yourself.
Biofuels.
I support 100%. The algae-type fuels, this is a totally new area, Jay. This is the promise of humanity, is biofuels.
Hydroelectric.
Well, you need a river that you can dam up and build a big lake behind it. And if that concrete ever gives way on the dam, look out below.
Geothermal.
Not cost-effective. You have to drill so deep before the earth heats up. You're spending more money than you're making.
Energy storage.
Energy storage is getting better and better, I have to say. So I'm all for that.
Electric vehicles.
I support them 100%. I wish I had the money to buy one, but I don't.
Energy efficiency.
Energy efficiency is of the utmost importance, Jay.
Yeah. And then finally, nuclear fusion.
I'm not sure that fusion reactors actually exist.
And something that probably is far in the future, like we would expect lightning would be. All right, Steve LeRoy, thank you so much for your time.
You're very welcome, sir.
That was Steve LeRoy, inventor of one of the world's only successfully demonstrated lightning-to-power technologies. And if you know how to get him his money he's owed, I'm sure he'd greatly appreciate it. I also want to thank Steve for agreeing to this interview, and I think it helped me get some things off my chest that I've wrestled with over the years. I also want to thank John Glassy, the New York Times feature writer who helped put us together. All guests are sent the raw and completed audio the week of release. So far, no complaints. Music was produced by Sean Stroop at Stroop Loops. You can check out pics of Steve's original patent, which he was kind enough to share on Instagram at Host Energy and online at energy-cast.com. That wraps up episode 41. Be sure to join us next time when we learn how blockchain technology could bring greater value to the renewable sector. Until then, I'm Jay Downhauer. We'll see you next time.